Okay, the fifth technique is to use the quadratic formula, which one of the best parts about technique number 5 is that you can use the quadratic formula with any quadratic equation. Okay? The zero factor property only works if you can factor it. Okay? We know that there's plenty of quadratic equations that you can't factor. Okay? And so therefore factoring doesn't work. Okay? Completing the square is a process that's kind of nice, but yet we had to deal with a bunch of fractions when we did that the last time. If we used the quadratic formula for that last example that we had, okay, we wouldn't have had to bother with all those fractions. So we might have chosen, if we recognize that, whenever there's an a in front, we might say, well, let's just use the quadratic formula. That's way easier. Okay? In fact, we're going to do just that. Now, I particularly like to teach a series of steps to be able to make sure I get this right. So I'm going to show you the way that I would do it, just to keep everything straight. Because if you just start throwing numbers in there and doing a bunch of math, okay, you may or may not keep everything straight. So what I like to do is do it in the following steps. Okay, the equation that we were given, and we'll do it with our same equation we had, remember it was 3x squared minus 2x minus 10 equals 0. Okay, and that was our equation. So my first step in using the quadratic formula, and keep in mind that this formula is something that doesn't have to be memorized, that's on your note packet. Okay. After doing it a few times, you probably will have it memorized whether you like it or not. Okay, what I like to calculate is the first is to do the b squared minus 4ac part. And you'll notice that I added something in there. I put parentheses around the 4ac because that's usually the most common mistake I see. Okay, so identifying a, b, and c then. Okay, if I just do that part only, keep in mind that's the part that's under the radical in the formula. Okay, if I were to plug in my negative 2 squared minus 4 times 3 times negative 10, okay. And once again, I put it in parentheses because I want to make sure that I carefully multiply these two before I deal with the subtraction part. Okay, that's where people generally mess this up. They don't put parentheses around that, and then they get these signs all messed up. Okay, so if I do that, I'm going to get 4 minus, and in the parentheses, I'm going to get negative 70. Nope, I lied. About negative 120. Yeah. All right, so that would make 124. So 124 would be our, and this actually has a name. This is called the discriminant. We'll talk about that later, but we're calculating the discriminant first. Okay, and there's information about the formula or about the equation we can get from the discriminant, but again, we'll leave that for later. Right now, we're just going to focus on the solving part. Okay, so once we do that, then step 2 is we're going to take the square root of the discriminant, okay, and simplify it if necessary. Okay, we might, in this step, we might be already done. Okay, but we know that 4 will go into that for sure. Okay, so if we wrote that as 4, and 124 divided by 2 is 62, and that divided by 2 is 31, should be a familiar number based on what we just calculated a minute ago with our other method. But we ultimately get 2 radical 31 for the result. So that is actually 2 radical 31. Okay. Now once I calculate that part, okay, I really have that whole thing done in this formula. So now all I got to do is worry about the b and the 2a here. Okay. So when I fill out the whole entire formula this time, I'm going to go opposite of b. And especially if the b is negative, I would put it in parentheses, plus and minus. And once again, you already calculated the hard part, okay, in steps 1 and 2. Okay, that part's already done. True? Okay. And then at the bottom is 2a, so 2 times a in our case would be 2 times 3. So from there, with simplify, positive 2 plus and minus 2 radical 31 over 6. And then the last step you got to recognize, and you may or may not have a last step at this point, but if the 2, 2, and 6, if the 3 parts that are not under a radical, if all 3 parts have a common factor, then we can reduce by that common factor. Okay, another way to think about it is the fact that these 2 on top have a 2 in common. We could factor out the 2 and we'd be left with that. And then we could reduce it with a 6. And we'd ultimately have 1 plus and minus radical 31 all over 3. Okay. All right. Now we might say that looks a little different than what we did with the completing the square part. Okay. But remember, if I have this 1 plus radical 31 divided by 3, I can change that to have them divided individually as well. Okay. These two things are equal. And if you remember when we did it with completing the square, we got this as our answer. Okay? But those two things are exactly the same. So we might ask, which way is better? Okay, if it were me, if there's an a in front, some number besides 1, I would use this technique every time, okay, if I had a choice. If it said use completing the square, then you don't have a choice. But ultimately, I would use this technique every time if you have a choice. Okay. Questions so far? Yes?
For our test, will the formula from method number 4 be on
I can't remember. You'll have to look on the. I'll look at it and find out. I'm not sure. I can't remember that. Bottom line is, if you practice it enough, you probably will have it memorized whether you want to or not. I do want to show one more quadratic formula problem, just to illustrate that even if we have a factorable equation, like this one is factorable. Okay? But we can still use the quadratic formula. I want you to see what happens, though. Okay, they did it the opposite of me. They just threw stuff in there and started doing the math. If you're comfortable enough to get it right and do it that way, you can skip my steps. But I like to use my steps because it keeps track of stuff a lot better. But bottom line is they got down to this point and they ended up with a 49 under there, which 49 is a perfect square, isn't it? So that means they got a 7 here instead. If you get a 7 here, then you can actually get 2 answers with no radicals. But you make sure you do it this way. When you do -3 plus 7, that's 4. And 4 divided by 4 is the 1 that they got here. And then they did -3 minus 7, that gives us -10. So it would be -10 over 4, which reduces to -5/2. Okay, so even though it factors, you can still use the quadratic formula. So, like I said at the beginning, that's why it's nice, because you can use it for every quadratic equation if you want to. Okay, whether it factors or not. Whereas factoring, you can only use if it factors. Okay. All right. Questions on using the quadratic formula?